In this problem, we're going to analyze an exponential growth model. Let's read this problem. Only 1.7% of the world's population used the internet in 1997, whereas 28.8% of the world's population used it in 2010. Assuming continuous exponential growth, find the year in which the percentage will reach 100%. The key phrase here is continuous exponential growth. That means we're going to be using an equation that looks like this. A equals A naught e to the RT, where A is the population after a given time t, A naught is the initial population, R is the constant, and T is the time, in this case, in years. Okay, let's pick this apart. Notice that in 1997, which is our initial case, we have a population using the internet of 1.7%. So here's what I know. I'm going to let t equals 0 correspond to the year 1997. Okay, so let's just make that known so that we remember this at the end. This will be important. The other thing is that the initial population at that year is 1.7%. I can leave my whole problem in percents. Whether you choose to write this in decimal form, 0.017 or 1.7, it's fine either way. Just remember what you're dealing with. So I know that my initial population, A0, is 1.7, and this is percent of the world's population. Okay, I need to first of all figure out what this constant R is. And that way I will be able to then figure out at what year the percentage will reach 100%. So here's what I have. I know that in the year 2010, we have a population of 28.8%. So here's what we know. T equals 13 corresponds to the year 2010. So let's keep that in mind. Now, the population in that year was 28.8%. And then following this format, I know that A naught, or A, is 1.7, and I have E to the R, and again, T was 13. So I can then just make some basic calculations. What I'm going to do is isolate this E to the R times 13 on one side. Let me just do that. We get 16.94 equals e to the 13r. Now what I want to do again is solve for this r, so what I'm going to have to do is take the natural logarithm of both sides. In other words, ln of 16.94 equals 13r. I can solve for r and get an approximate value for r. Let's just do that really quick. In solving for r, we get r is approximately 0.22. Now that we have this constant, we can then use that to help us figure out in what year the percentage will reach 100%. Let's just make some room over here. I'll leave this equation up so that we know what model to follow. Now the population in the final year will be 100%. Since I was dealing with 1.7%, I remember I said keep in mind that what you're dealing with, since we had 1.7 and 28.8, I want to put 100 here as opposed to 1. The initial population is still 1.7. We have e to the r. R we now know is 0.22. And we want to solve for this value t. First of all, I need to divide both sides by 1.7. We get about 58.82 equals e to the 0.22t. Now what I want to do is, just like we did before, take the natural logarithm of both sides to isolate t. Let me just do this right over here, make some room. I need to take the natural logarithm of both sides in order to isolate t. So I'll get the natural logarithm of 58.82 is equal to 0.22t. I can then approximate t. Let me divide both sides by 0.22. We get t is approximately 19. What we want to do is remember that it's not in the year 19 that the population reaches 100% because my initial year was 1997. Therefore, I'm going to add 19 to 1997 and I get 2016. So in the year 2016, the population will be 100%. So around the year 2016, all of the world's population, according to this model, will be on the internet. In this problem, we use the model of exponential growth in order to solve an application.